Welcome back. So now on part 7e, we move into a new type of reaction. These reactions are going to be the redox reactions. Basically, reduction and oxidation. And we cut it down to redox. So every time you hear redox reactions, we're talking about reactions where reduction happens and oxidation happens. And what is that? Well, let me give you a quick way to remember, especially since we are here in Texas, and especially if you travel west, you're gonna see a lot of oil rigs, which is gonna be oxidation is losing, reduction is gaining. And in this particular chapter, this is just a quick introduction into redox reactions. We're going to have another chapter where they're going to go deeper into it. Also, the way the textbook explains this, I don't like it much because it's just pure memorization. So I'm going to show you a way of doing it, which is by analyzing and using the concept you know. And it's going to be so much easier than memorizing. So let's do that. So we're gonna be able to look at a reaction and immediately decide or identify the reaction as a redox reaction or not. And once we do that, we're gonna look at the specific type of redox reaction, which is combustion. But this one follows a particular pattern and is very essential for our way of life. Most of what we know today depends on combustion of fossil fuel. So it's super important that we understand this so we can say then, okay, so we can do this on a better way that doesn't hurt the environment and it will be cheaper for me on the long run. And by understanding combustion now, then we can move into a society later where combustion is not the main engine of progress. Nothing wrong with it, but it's time to move forward. And yeah, there's some things that are wrong with it, very wrong. So let's see. So how do we know if a reaction is a redox reaction or not? Like I told you before, we're not going to memorize if it's reacting with a metal or not. We are going to say, okay, what chemistry do I know? Well, I know that this is a ionic compound. Therefore, it's made out of ions, and the ions on this specific one are going to be magnesium, which is 2 plus because I know it's on group number 2, and oxygen, which is 2 minus because I know it's on group 16. So you are not memorizing anything, you're just using what you know. And this magnesium is by itself, so there's no charge, and this oxygen is by itself also, so there's no charge either. So how do we go from that into being reduction or not? Well, you're going to look at the changes. You're going to take magnesium and you're going to compare with the magnesium cation. So from magnesium, it's going to go to magnesium cation. So what is the difference here? It's going from 0 to 2 plus. And how do we apply oil rig to this situation? Oxidation is losing, reduction is gaining. Well, we're going to be talking all the time about electrons. And electrons are negative. So is that the only thing I'm going to use to compare this? If I go from 0 to minus 2, am I gaining electrons or am I losing electrons? If I gain electrons, I become more negative because electrons are negative. If I lose electrons, then I'm losing negative, so I become more positive. So that's the answer. On this particular case, I'm losing electrons. And I'm precisely losing 2 electrons. So this one is oxidation, because oxidation is losing, as simple as that. What about the oxygen? Well, the oxygen is becoming oxygen 2 minus. And just to keep, so we don't violate the law of conservation of matter, we put a 2 right in front. So, once more, am I gaining electrons or am I losing electrons? Which one it is? Well, I'm going from 0 to 2 minus. So how can I go from 0 to 2 minus? That means I'm becoming more negative. So the only way for me to become more negative, if all I can do is gain or lose electrons, is by gaining electrons. And specifically, I'm gaining 2 electrons. And since I'm gaining electrons, I know that reduction is gaining. So this is the reduction. So one of the elements is undergoing oxidation. The other one is undergoing reduction. So therefore, this is a reduction-oxidation reaction or a redox reaction. Reduction cannot happen unless oxidation happens at the same time. If I lose electrons, something has to take those electrons. So this is definitely a redox reaction because we prove that there's a gain and a loss of electrons. Let's do another one so we can start developing a brain in our pattern. A pattern in our brain. Sorry, my brain pattern system is not working too good today. So let's see. So on this one, we have HBr, which we know is an acid, hydrobromic acid. So that's going to be H plus, and this is gonna be Br minus. This is an ionic compound that is going to give me Ca2 plus and OH negative, 2 of them. So we're doing nothing different from what we did on the previous part when we were doing the total ionic and the net ionic equation. And here we're going to have water, and here we're going to have Ca2 plus and 2Br negative. So let's see what happens. By the way, the water, we can see the water as H. It's not really like that because water is not an ionic compound, but we can visualize it. So this is just visualization. That's an I, by the way. So let's see what happens. So the H plus is still H plus. The bromide is still bromide. The calcium 2 plus is still calcium 2 plus. And the OH negative is still OH negative. So as you can see on this one, there hasn't been a loss or a gain of electrons. So therefore, this one cannot be a redox reaction. We proved that it's not a redox reaction because we didn't observe any gain or loss of electrons because the charge will have to change on this particular one. On this particular one, all the charges remain the same. So that one is not a redox reaction. That is just a neutralization reaction, a reaction between an acid and a base. So let's look at the last one. So the last one, we have calcium by itself. And when an element is by itself, it's the same as having a 0. We have chlorine by itself. There's 2 of them diatomic because it has to be a diatomic. Therefore, we can say that that's 0. And this is an ionic compound that can break into calcium, which we know is 2 plus because it's on group 2, and chloride, which we know is -1 because it's on group 17. And for the purpose of keeping everything straight, there's 2 of them, right? So what happened here? The calcium becomes calcium 2 plus. So the calcium is becoming calcium 2 plus. The chloride is becoming, the chlorine is becoming chloride. The IDE means that it's negative at the end. So the chlorine is becoming, two of them, chloride. So this one is going from 0 to 2 plus, and this one is going from 0 to 2 minus, because there's two of them, right? So to go from 0 to 2 plus, are we gaining electrons or are we losing electrons? To become more positive, you cannot gain negative, so you cannot be gaining negative. You have to be losing electrons, and you're losing 2 electrons to give you 2 plus. So oxidation is losing, So this one is my oxidation. This one, are we gaining electrons or are we, actually, sorry, that's the same one we just did. I need to go one lower. So this one, are we gaining electrons or are we losing electrons? It's going from 0 to 2 minus, so we definitely have to be gaining 2 electrons. Reduction is gaining, so this one is my reduction. So yes, this is a redox reaction. This is a redox reaction, and this one is not a redox reaction. So that's my advice. Do it like that, because if you do it like that, you're using everything that you have already learned, like recognizing an ionic compound, breaking it into the ion, using the periodic table to find out the charges, evaluating the situation, seeing if they're gaining or losing electrons. Will memorizing it be faster? Yes. But then that means that the next thing you learn, you're also going to have to memorize it. And before you know it, you're going to be overloaded and you're going to forget when it's important. If you learn it like this, you're just reinforcing what you already know. And when you find out, when you're confronted with something new, more complicated, your foundation is going to be so strong that it's going to be really easy for you to get it. But that's just my advice. Obviously, you will do whatever you decide to do. So that's your daily work. So make sure you practice that and reinforce everything you already know. So what about this one? Complete and balanced each combustion reaction. So a combustion reaction, like I told you before, is a very special type of redox reaction. This one doesn't deal with ionic compounds, so we cannot see it the same way we saw it before, where we break it into the ions. For this, you will need more knowledge that you don't have right now. So for this one, as long as you can recognize it as a combustion reaction, you know it's a redox reaction. So how do I know I have a combustion reaction? Because you have something that needs oxygen to burn. And if this something happens to be something with carbon, hydrogen, and oxygen, you most likely are going to get carbon dioxide and water. So that's the typical combustion reaction, where when you're burning some type of fossil fuel, to burn anything, you need air, because you need the oxygen from the air, and oxygen is a diatomic molecule or a molecular element, and you're going to produce CO2 and water. And this is the reason why we have to move to a non-fossil fuel society, so we don't continue putting CO2 into the atmospheres and contributing to the cycle of global warming. So once more, if you have a combustion reaction, you just need to recognize that you have something that is burning with oxygen, producing something else. And I told you already, if what you're burning contains carbon, hydrogen, or oxygen only, then you're going to get CO2 and water. The CO2 is a gas, and water is a liquid, but because this is combustion is burning, it produces a lot of heat, it's actually gonna evaporate. So it's actually you're gonna see it as a gas. And can I prove this to you? Yes. when you go out into the road today, over 70% or over 90%, over 90% of the cars that you're gonna see on the road today, they're combustion engines. And there's a pipe coming out of the back of the car. If you see a lot of water coming out of it, then combustion engine produces liquid water. If you don't see anything coming out of it, that means there is water vapor coming out. And if it happens to be really cold that day, when that gas comes out, it's gonna condense, and sometimes you're gonna see it dripping water from the pipe. That's how we know there's a gas coming out. So, and then we just have to balance. So let's balance this particular equation. So we have the left, we have the right, and we have carbon, hydrogen, and and no oxygen in this case. So we just carbon and hydrogen. We got on the left side six carbons. Oh yeah, we do have oxygen because we have oxygen O2, right? And we have two oxygens there. On the right, we have one carbon, two hydrogens, and three oxygens. So on the right side, we're gonna multiply by 6 where the carbon is. So we multiply by 6, but that's also gonna change the oxygen. So now I'm gonna have 12 oxygen plus 1 there. So now I have 13 oxygens. And then let's fix the hydrogen. We're gonna multiply by 3 to take care of the hydrogens. But that changes my oxygen. So now I'm gonna have 12 oxygens plus 3. So that's actually 15 oxygens. So my carbon is balanced, my hydrogen is balanced. I just need to balance my oxygen, which I'm gonna multiply by 7.5, which is gonna give me 15, right? 7.5 is 15. So it's gonna be 7.5, but I cannot leave it like that. So the lowest number that I can multiply 7.5 by, that will give me a whole number, is 2. 7.5 times 2 is 15. So I'm gonna multiply everything by 2. So that means I'm gonna have a 2 in there, a 15 there, a 12 in here, and a 6 in there. So let's find out. Let's double check, make sure we did it right. So carbons, 2 times 6, that's 12. 12 times 1, that's 12. Hydrogens, 2 times 6 is 12. 6 times 2 is 12. Oxygens, 15 times 2 is 30. 12 times 2 is 24. Plus 6 times 1 is 30. So that's balanced. So that would be my balanced combustion reaction. What about the next one? Is the next one a combustion? Well, let's see. Do I have something plus oxygen, and it's O2 because it's oxygen by itself? So this one doesn't have carbon, hydrogen, or oxygen. This one has calcium. So how do I know what I get? Well, you're gonna combine calcium with oxygen, right? Calcium is 2 plus, oxygen is 2 minus, so you're gonna get a ionic compound. You're gonna get CaO. And ionic compounds, most of the time, they're gonna be solids. So that's what we get on that one. And calcium, I can tell you from experience that if I put calcium, pure calcium in water, it's gonna get really hot. So it's gonna generate a lot of energy. And it can catch fire, depending on what's around. So this will not catch fire, but if you happen to have it on a paper cup, the cup will catch fire, most likely. So calcium, let's see, one calcium. So we're gonna need a 2 in there that will take care of the oxygens. The calcium will change to 2, so I put a 2 over there. So that would be a balanced equation, and that would be combustion also. And the next one is carbon, hydrogens, and oxygens reacting with oxygen gas. So that's definitely going to give me CO2, which is a gas, and water, which is also a gas. And you already know why water has to be a gas on this case. And we're going to balance. Let me see if I can. Let me show it to you how I can balance without using the table. So ideally, at one point, you will not need to use the table anymore. So I have 3 carbons, so that takes care of that. I have 8 hydrogens, that takes care of that. And now I have 6 oxygen plus 4, so I got 10 oxygens, that takes care of that. And this is balanced. And is this a combustion reaction? Yes, it follows the pattern. Something plus O2 producing CO2 and water, or producing an oxide with a lot of heat. So all these reactions, for them to be true combustion reactions, they have to produce a lot of heat or energy very fast, like when something is on fire. And that's how we know a combustion reaction. So this is your daily work. Make sure you can recognize which one are combustion, and make sure you can complete them. So you should be able now to complete a combustion reaction if it contains carbon, hydrogen, or carbon, hydrogen, and oxygen. Then your products are always CO2 and water. If it's a metal, then you're gonna get an oxide of that metal. And with that, you now have the tools you need to recognize if you have a redox reaction, reduction, oxidation. Oxidation is losing, reduction is gaining electrons. And now you can also identify and write or complete a combustion reaction. So that's it for right now. So we have one more section to go, and that will be the end of this chapter. So looking forward to see you soon. I most likely will be recording this one today also. Take care. Have a wonderful day.